Hey guys, back at you with day 59. I just wanted to get on video what we talked about a little bit today in class. So here's an example problem that I want to kind of go through. It's given that f of 2 equals 5 and f prime of 2 equals 4. It's also given that f double prime of x is greater than 0. It says use the tangent line to estimate f of 1.9. And then I want to know, is your approximation an overestimate or underestimate? Explain. Okay, to get the tangent line equation, I only need these first two pieces of information. These two pieces of information will help me to write an equation for a tangent line. Then I can use the 1.9, right, when I'm trying to estimate. I can use the 1.9 in my tangent line equation to get my estimate, okay? So to do all this, I don't have to use anything with f double prime of x being greater than 0. That piece of information is going to be important for determining whether my approximation is an overestimate or an underestimate. So to solve this problem, my first step is I want to write the equation of the tangent line. Okay, well, to write an equation of a tangent line, I need a point and a slope. Okay, my point is the point 25. And my slope is the derivative f prime of 2, which is 4. So right away I can get a tangent line equation very easily of y minus 5 equals 4 times x minus 2. So there is my tangent line equation. And I'm going to use that tangent line equation evaluated at x equals 1.9 to get my best guess of what f of 1.9 is. So I'm going to go ahead and plug that in. I'm going to get y minus 5 equals 4 times 1.9 minus 2. Okay. 1.9 minus 2 is, here's where you need to be careful, negative 0.1. Four times negative 0.1 is negative 0.4. And now I have to add 5 to that. Again, this is a place where, all right, you got to do this without a calculator and make sure you're accurate. I got to add 5 to negative 0.4, and I get y equals positive 4.6. So right away I can say f of 1.9 is approximately 4.6. Okay. So that answers part 1 of the question. Okay, next, I have to answer the question, is your approximation an overestimate or an underestimate? Well, I never used the fact that the second derivative is positive. I haven't used that piece of information yet, so that's probably the piece of information that's going to be helpful for me to solve this problem. What we need to know by looking at that is if somebody says f double prime is positive, we know right away that f, the graph of f, is concave up. So what I do is I just sketch a concave up graph. And we know when f is concave up, f is smiling. So what we have here is our graph of f. And think about what we used. We used a tangent line. Right? You just put this tangent line anywhere, it doesn't matter. Here is my tangent line. Right? So I plugged in 1.9 on my tangent line, which is like maybe right here. And I want to know, how does that compare? Right? So this is my 4.6. This right here, this point, I'll use yellow. This point right here is what actual f of 1.9 is. Hopefully you can see that color. I can't see it very well at all. Well, by looking at this, I can see that my 4.6 is going to be too low of an estimate. It's going to be an under approximation. Because anytime my graph is concave up, right, f is concave up, that was given information, I know that my tangent line is always going to lie below the curve. So I'm going to say 4.6. 4.6 is an underestimate. because f double prime is greater than 0, therefore, sorry, my handwriting's bad here, therefore f is concave up, and the tangent line is always going to lie below the curve. Anytime we have a concave up function, the tangent line is always going to be beneath the curve. Therefore, we're always going to get approximations that are too low. Conversely, if f was concave down, that means my tangent line would always lie above the curve and make my answer an overestimate. Because again, the tangent line is going to lie always above the curve. Okay, so that's what we were talking about today in class. I just wanted it on video for anybody who wasn't there to make sure we know what's going on. Okay, so concave up is always going to give an underestimate. Concave down is always going to give an overestimate. Instead of trying to memorize that, just sketch a graph of a concave up graph, and you'll see that that tangent line is always below the graph when f is concave up. Whereas conversely, right over here, if I have a concave down graph, my tangent line lies above the curve. Therefore, I always have an overestimate rather than an underestimate. Okay? We'll talk more about this on Wednesday. That's it for today. Another short one. Just make sure you watch it. Tell your friends. Spread the word. 2 chains. Bye.